Right, so first of all, the basic theory of flat Earth is that this is the Earth. It's flat, and basically the sun, the equator is here, and the sun just rotates around like this. And the when it's winter for the middle hemisphere, the the sun will go outwards slightly, and then uh, when it's um, when it's summer, it'll come closer in. So that's just generally the basic theory. So what I notice is there's a lot of lack of models, details of the models of flat Earth models online. So I did notice that some guy was trying to have a GoFundMe for for the flat Earth to make a model, a 3D model, but there was zero people wanting to sign up for that, and so he did another crowdfunding, and again, which was current last time I saw it, but again he had nothing. So I've made basically a cross-section model of the flat Earth, and as you can see, this is the North Pole. There's equator, the so-called equator, on both sides, which is where the sun goes around. So it would you basically be going like this in this model. And so because I'm in New Zealand, I've basically just made a plotted New Zealand. Now this is the interesting thing, which is I think is like very good proof that it's not to discredit the flat Earth, is that this is midday for New Zealand, for Wellington, New Zealand, and so there's Auckland there is just a little bit closer, and but anyway, there's Wellington, and basically because we know that basically what the flat Earth has done is that they've given us thus the most popular numbers for the distance of the sun away from the Earth, and also the distance of the sun away from the North Pole. So on average, it's obviously going to be moving towards the North Pole in the summer and away from the North Pole in the winter. That's for the northern hemisphere part of the world. But that's the average distance from the North Pole. So because we've got that measurement from the North Pole, and because we can also measure distance from Wellington and Auckland, from Wellington to the North Pole, we can calculate the distance of the midnight sun. So and also the angle of the midnight sun. So basically, to get the angle, we just take that distance from the North Pole to Wellington plus that distance again, and basically form a square angle triangle, and basically using a bit of trigonometry, it works out to be approximately 11 degrees for the sun as viewed from Wellington at midnight. So that's so anyway, I've never seen the midnight sun in Wellington, and I don't think anyone will ever see that, but I think that's basically the best proof. And in my next video, I'm just basically going to get an angle out. I've basically made basically what I've done is I've made because I don't have you can only buy small project tractors in New Zealand that I've come across anyway. So basically what I've done is 3,000 miles. If you divide it by 150, and if you divide that big number, 15 and a half thousand miles by 150, then you can create basically you get a much smaller number, which we can make a kind of a anyway, make a right angle to get that angle on a kind of larger scale. So I've made basically this larger angle here, and which is basically we'll be able to use an outside to get the 11 degrees and see how big that is on a larger scale.